instantaneous speed. And we're going to think of it as velocity from here on, so that when things are moving towards the ground, it'll have a negative velocity rather than just speed, which is always just positive. So the sign will matter. But if we talk about instantaneous velocity, that's the limit as h approaches 0 of the position function replaced with t plus h minus the original position function all over h. That calculates instantaneous speed, well, instantaneous velocity in this case. But if you look at it, isn't that really similar to just the definition of a derivative? Yes. If we take out the t's and the s's and we put it in f's and x's, that's the same as the derivative, right? So basically what we're trying to say here is that the velocity of a function can be found if you know the position function. It can be found by simply taking the derivative of the position function and substituting in the time you're interested in. So that's what instantaneous velocity is. It's really easy. You just take the derivative of the position function and substitute in the time you want to know the velocity at. Okay? All right. So one more time. How do we find the velocity of a function? Take the derivative of the position function, right? And that will give you the velocity function, and then you can substitute the time in. Okay, so what we want to do is we want to find the instantaneous velocity of the ball from the previous problem 1 second after being dropped. So we need to look back and we need to figure out what was our position function in that previous problem. It was s of t equals what?
Negative 16t squared.
Negative 16t squared.
Plus 100.
Plus 100. Okay? So there's our position function. That tells us at any second, like if I take a t value and I substitute it in there, it tells me how far off the ground the object is. Y'all understand that? And this was the position function from a ball that was dropped from a height of 100 feet. So this will tell me how high off the ground it is at a given time. If I want to find velocity, I do that by just taking the derivative of the position. So what's the derivative of this guy?
Negative 32t.
Negative 32t plus 100, what's the derivative of 100? 0. So it's really just negative 32t. So this right here is the velocity function. That will tell you the velocity of that ball at any given time, unless it's a time after it's already hit the ground, which we'll talk about later. So I want to know when t is what? 1. So all we do is take the derivative and we substitute 1 in. So we have negative 32 times 1 second, and that gives me a velocity of negative 32, and our units here were feet and seconds, so feet per second. And that's how you calculate instantaneous velocity. We're going to talk now about where the position functions come from. The position of an object in free fall is always given by the equation, and this particular textbook uses s's, some use y's, some use h's for height, it doesn't matter. But we're going to use s of t, which will be the height off of the ground at a given time, will always equal 1/2 times the acceleration due to gravity times the time squared, plus the initial velocity times the time, plus the initial height, which is that s. So v stands for velocity, and the sub-zero stands for initial. I think in physics sometimes we do v sub little I, right? Mm-hmm. Yeah. And this one just stands for the initial height at time 0. Okay. Now all you need to know to figure that out is you have to know what the two gravity constants are. Acceleration due to gravity. So if you're in feet, that is negative 32 feet per second squared. But if you're in meters, it's negative 9.8 meters per second squared. And so you just substitute in the g that you need to use, the initial velocity, and the initial height. And that's where all of these position functions come from. So let's take a look at this one. An Oompa Loompa throws a ball straight up from the edge of a platform. The equation of the ball's path is given by the function s of t equals negative 16t squared plus 16t plus 32. Now, you should be able to figure out by looking at it whether it's in feet or meters. if this number right here is negative 16, that's half of negative 32. So we know that that is in feet. So that's your first clue. If the number in front of the t squared is negative 4.9, then you're in meters, because that would be half of negative 9.8. And based on what we know, I want to know which of those numbers represents the initial height.
32.
Okay, and we have to give units.
Feet.
32 feet, perfect. So we do want to kind of start understanding what it is we're looking at. It'll make you more comfortable with word problems if you start to understand where all these numbers are coming from. All right, based on the given function, what is the initial velocity?
Negative 16.
Let's take a look. The formula says that the coefficient of the linear term is your initial velocity. So what's in front of the little t there?
16.
Positive 16. So my initial velocity was positive 16 feet per second. Perfect. So what that means, because it's positive, is that the Oompa Loompa threw the ball straight up. It's positive. If the Oompa Loompa had thrown it straight down, it would have been a negative 16t. Now this term is always going to be negative in a position function because that's how gravity acts. It always pulls things towards the ground. It does not shove them away from the ground. Which, that would be an interesting world to live in, wouldn't it? Do you have any questions about those two? Think we understand it or starting to get an understanding? So over time, I will ask you to become fluent with this. You should be able to, if I give you the initial velocity and the initial height, you should be able to write the position function on your own. So we'll do more and more of this as we build on it. So continuing with the same problem, we now want to find out when the ball hits the ground, because that's kind of when this function ceases to be an appropriate model. Did you guys understand that? Like that s of t equals negative 16t squared plus 16t plus 32, that's only going to work in this situation from the moment that the Oompa Loompa throws the ball until the moment the ball hits the ground. Once it hits the ground, we can't go beyond that time. So we say it has a very restricted domain. It's going to start at a time of 0 and go until it hits the ground. Make sense? So we want to calculate when does it hit the ground. What am I asking you to find? S or T? T. I'm asking you to find when. So when is a time? So we know we're looking for a time when the ball is on the ground. So what's its height off of the ground if it's on the ground? 0. So I'm asking you to figure out the time when the height is 0. So which of these represents the height? S of t, right? Now 32 is your initial height. So that's where it started from. And then we want to figure out how long did it take it until it hit the ground. So to figure out any time that it hits the ground right here, we sometimes call that impact. We're going to set it equal to 0 and solve it. It has nothing to do with calculus. This is strictly algebra here. In fact, I think we did these in college algebra just the other day. So we want to know when it hits the ground. So we set it equal to 0 and we solve it. We have a trinomial, and I think it's divisible by 16, right, or negative 16. So we could do the quadratic formula, but since it looks like it'll factor, I'm going to go ahead and factor out the negative 16. So we have t squared minus t minus 32. No,
Minus 2.
just kidding. Minus 2. Okay, so that's what we know so far. We want to know what the time when it's going to equal 0 there. So let's see if it'll factor again. That will give me t minus and t plus 1. So it looks like the only two possibilities are at 2 and negative 1 seconds. But negative 1 would pre-exist the problem. That's what I mean by saying, like, this parabola acts as if you could let time be negative infinity to positive infinity, but you can't. We can only let time be 0 and up. So which of those is the answer to our question? 2. The ball hits the ground 2 seconds after it was released. Is that okay? Yes? Okay. So now for the final question, we want to know what is the ball's velocity at impact. So we want to know what was its velocity when it hit the ground. So how do we find velocity?
You plug in the 2. Because it's
We do at the end, but I need a velocity function. I don't have one yet. How do we find a velocity function?
Derivative.
Take the derivative, yeah. So the velocity function is always the derivative. of the position. So in this case, it is negative 32t plus what? 16, and then the derivative of this term is 0. Okay? And so if we want to know it, this is the velocity function. Like that's what it is no matter what the time is. I want to know at impact. So you're right, we plug in the 2 and then we'll know how fast it was going when it hit the ground. What does that equal?
48.
Negative 48, and we are expecting a negative because it was moving downward when it happened. Right. So that's negative 48, and our units would be feet per second. So that's how we find impact and impact velocity.